Supercharged 50cc two-stroke engine running on nitromethanol. Currently not so supercharged, not running on nitromethanol. For troubleshooting. Welcome back to my garage. You saw the previous video. We're struggling with getting the engine to rev. Cuts out at around 12,500 RPM. There's a bunch of things we can try, and there's probably a lot of great comments on the subject. Thing is, I haven't been able to read and reply to any of the comments yet because I've been on a trip to my brother-in-law's cabin the whole weekend. I've been skimming through a few of them, and I know there's a lot of comments about this could be the limiter. It's set to 25,000 RPM, but maybe the ignition controller is somewhat confused and thinks that's 12.5. Quite a coincidence that it seems to be limited at 12,500 RPM. This got me thinking, I haven't removed all the experimental features yet. This is a normal Ignitec 1-channel unit. The one I'm running now, it's a 4-channel unit. I've piped all 4 of those channels into one coil, and that's not the normal way of doing things. Experimental. I'm gonna go back to this unit to remove another experimental feature for now. Problem is I've run out of spade connectors. Another problem is I've run out of fuel for my heater. The garage is currently sitting at hovering around 0. Floor level, we're talking negative something. It's really cold out here. You saw me welding in a bung and mounting an EGT probe. Turns out I haven't got any thermocouple amplifiers. We can't hook that up yet either. I need to go get some fuel and get this place heated up. Try to find a local place that sells thermocouple amplifiers and spade connectors. Some high quality ones. The previous ones I bought were shit. There's oil everywhere after the roof-mounted exhaust extracted fan sprung a leak, and a year's worth of two-stroke oil dumped onto everything here. I can't remember exactly what I said yesterday. We're troubleshooting why this engine doesn't want to rev past 12,500 RPM. I think I said I haven't been able to read many of the comments this time, and that's still true. We've removed another variable. We're back to the single channel CDI. Should be capable of well beyond 20,000 RPM. And I've revved the engine past 18,000 with this CDI. I've hooked up the EGT probe. It's connected to the computer. I couldn't find any thermocouple amplifiers locally. Head temp is currently not connected to the computer, but to this little gauge. Out of thermocouple inputs on the Dyno box. My coolant system was somewhat frozen. I usually manage to keep the garage above 0 degrees Celsius. I also weighed the whole weekend, and as luck would have it, it got really cold that weekend, and I wasn't able to turn up the heat here. I think we're fine though. I don't think anything broke. Let's start it and see if it revs, and then go from there. give it a little more timing. Let's give it 35 at 10,000 and then ramping down. Just to get it into where it's cutting out. The reason I installed the EGT probe is to see how cold the exhaust is. If the exhaust temperature is really cold, then the power band will be lower. And it seems like it starts at 12,500, around there, which is far too low. But it corresponds well with an average temperature in the pipe, which is around 200 degrees versus 350, 400. I'm starting to think it's carb treble though. Hollander knows a guy who had been experiencing very similar problems with the same kind of car, and an air filter seemed to fix the issue. I haven't got a filter that fits, so I've made this abomination. Let's see if it makes a difference. It'll probably run a lot richer now. Let's hope this stays on there long enough for testing. It might be that I didn't press record. It ran worse, and it started cutting out at like 10,000 RPM. Try a much smaller main jet and see what happens. We might melt the engine. I'll try to be careful. From 100 to 90 millimeter main jet. I'll lower the needle and make it leaner at lower throttle openings. It's hopeless at anything but full throttle. This might help it not become overly rich whenever I'm not at full throttle. Keep it from cooling down the pipe and loading up the engine. Maybe. Well, this is strange. I wonder if that 90mm main jet, if that's one of those I've drilled out. Should have a closer look at it. It seems much richer now. Yeah. That's like a 2.5mm jet. A 92mm, and I've confirmed that this one is not drilled out by your main presenter. Now let's give it some more timing. More timing. I'm still scared I'm running too lean though. And we need it to be this lean to get over the hump, but then it's too lean in the power band. Fairly low EGTs. I think we're safe for now. 22mm jet. I've never run this carb on anything, and I wonder, the emulsion tube is sticking up, like the needle jet is sticking up a lot here compared to many of the others. Might be this is a 4-stroke carb, as people call it. And that could be why it needs such a low jetting compared to what I normally use. I think there's some inconsistency in those jets, and this 85 jet isn't really smaller than the 92 that was in there before. I think it's still running rich, actually. I switched to this known carb to remove a variable, but it's actually not a known carb. It's a K-in, and all my other carbs are OCO and copy carbs. And the needle jet is sticking much further into the bore in this carb versus my other carbs. And also the slide cutout is much larger. That needle jet protruding much more into the bore. That's probably making it better at picking up fuel, making so that normal jetting, it's far too rich. We'll need to jet it down some more, or switch out the carb for something like this one, which has a normal emulsion tube needle jet thing. I think 85 is the smallest one I've got. And I think that 85 isn't really an 85, but larger than 92. 100 is the smallest in that set. I think that's supposed to be an 80. So this one's definitely smaller than the 92. Yeah, this is the smallest one. I think it's an 80. Let's try the 80 jet. Let's compare it to the 85 sitting in there now. And this one's definitely smaller. Let's try this one. Let's hook up the retarder and give it a little more resistance. Up until now it's just been the inertia of the assembly. Let's load it a little bit at higher RPM. Something going on with my brake here. Something weird going on here. I'll restart the software. There's something really strange going on with my brake controller. And I can see I'm leaking water. How can brake percentage be negative? Seems to be a bug in the software where I can't set where it should start ramping up the brake to a set percentage higher than 10,000 RPM. Above that, and it starts giving just random numbers, negative numbers for brake percentage, and the brake isn't doing anything, which is a bummer because I can't set it to ramp up to higher than 8% and start at 10,000 RPM to get over that hump. Seems to be running much better with a little bit more load. I think maybe the ignition unit is struggling to calculate stuff at higher RPM when it's accelerating so fast. Maybe. Seems plausible. I've updated the software. Let's see if that helps. When I think about it, we could actually just perform a run and the brake will adjust itself. Let's try that. It's starting to run better, and it seems like a little bit of load helps the ignition unit to cope with the acceleration, if that is our problem. We'll definitely need to tune the PID circuit to have the dyno not overshoot and struggle so much. For that last run, we're like hovering around 10 horsepower from 15,000 to close to 18,000, which isn't much. Jetting is probably quite a bit off, same with ignition. And the whole reed adapter assembly is fairly crude and there's a lot of sharp edges and mismatched pieces. It is tempting to machine up a rotary valve and use that for testing, confirm the soundness of the engine. And that would mean we could test it properly, actually see some numbers from this cylinder, naturally aspirated. Reed valves are not the way to go with the large crankcase volume. Speaking of that, a large crankcase volume is the way to go when it's on the pipe, because then there's no more pumping action from the piston. The pipe is doing all the work. And so would the resonant intake, if we would have installed that. That's experimental, but a rotary valve likes huge crankcase volumes, and I'm really familiar with tuning with a rotary valve. So that's not experimental. But how to drive it? I'll sleep on it and be back tomorrow. It's the next day. I've been thinking about rotary valves and such, but also about ways to make my dyno behave under a run. And I think I've come across a fundamental flaw in the design. Noise, especially noise on the load cell. This has been mentioned a bunch of times by several people throughout the lifespan of this dyno. Also by Jostein, who built and designed the dyno controller, your dyno controller. And especially Mikki Antonokakis, sorry for the pronunciation, has given me some insight into the numbers. I sent him the raw numbers and he did some analysis on the data. And he knows a lot more about this stuff than I do. I'll show you the noise in a little while, but I think I know why there's so much noise and why the noise is probably too much for proper readings. This is a piston. This is a Conrad, very short stroke. Here's a crankshaft. I should draw it in a different way. That's the counterweight. The piston moves up and down, and this moves around. The counterweight is there to balance out the force from the piston moving up and down. In a single cylinder engine like this, you can't probably counteract this force with this force. The best you can do, roughly speaking, is balance this force up and down 50% and the secondary force side to side 50%. Spread out the imbalance. You'll have a 50% imbalance in this direction and 50% in this direction, depending on the weight of your counterweight. You can vary the weight of the counterweight to shift these numbers, say 70, 30, or 10, 90, whatever. 50 is the most even you can get. You'll never get better than 50-50 on a single cylinder engine. I think this can be a huge problem with the load cell mounted to the engine, like I've done. The reason for doing it like that was to remove all the transmission losses and inertia from the dyno, everything out of the equation. The problem is that the force acting on the piston and the rod and the whole crank assembly from combustion is completely dwarfed by the force from this up and down motion. The imbalance is probably not centered on the crankshaft. It probably sits outside the crankshaft, depending on RPM. And this creates lots of force on the load cell. And this large force can probably dwarf the small readings from actual torque produced by the engine. A theory. I think we'll have to go for a more conventional setup. Mount the load cell to the retarder so it registers how hard the retarder has to push back. It's not that much work. We'll need a couple of bearing blocks, suspend the retarder, and have the load cell mounted on a lever arm. This is torque readings from the load cell. The red line is without smoothing and the green line is with smoothing. This is versus time. This is versus RPM. You can see how it's a complete mess. I don't think we're getting actual power readings. I think we're getting an average of these up and down forces combined with the weaker actual torque and various weird resonance issues because of that. There's probably a lot of people saying I told you so. I had to try. I've always known this was kind of an issue, and the plan was to add some kind of a dampener, something. Maybe in software, maybe an actual physical damper, like a steering damper. After thinking about it, I'm not sure that would help. If those imbalance forces are much higher than the actual torque forces, then it wouldn't help with a damper. It would just dampen the, like, the actual torque would still be dwarfed. Could be. Just a theory, without much to back it up, but it sounds plausible. Did I mention how cold it is out there? I turned off the heater 5 minutes ago and it's already freezing. Getting close to the point where black holes will start evaporating. Do some more testing, regardless of the dyno needing a major redesign. I've been running power sweeps up until now. We're gonna try the RPM curve instead. I've programmed the curve where it's supposed to stay at each RPM point for 5 seconds and then quickly move up to the next one. Starting at 12,000 and then 13, 14, 15, 16, 17, 18, you get the drill. The cylinder is completely fine. I know what the problem is. I ran it out of fuel. That was really stupid. I actually let off at the pointer where I thought it was running the bowl dry. And it actually was. But then I immediately changed my mind and thought it was the plug or maybe the reeds or the ring or something. Anyways, we'll have to reassemble, but this time I'm gonna use this carb. This is actually perfectly suited for this. I can remove this and create a little plate to mount this in place of this directly onto the reed block. We'll have a much nicer intake. And this is an actual known carb for me. The one I've been using, I've never used that on anything else before. It has that high needle jet, which I think is making jetting weird. This one has the normal needle jet. This carb is borrowed from my Death Trap bike, and I know how it behaves. I've been running it before. Just out of curiosity, it would be interesting to mount this as a valveless intake, but with the sliding reed valve in there, so that the reed can be pushed away in the power band. Because with this carb and the intake and that reed valve, we're pretty much at the length I calculated for resonance in the engine. Even though we're trying not to be experimental at the moment, it would be fun just for testing, see how it behaves. See how it behaves. Can't be a coincidence that this carb is the perfect length to make this work. It's not the perfect angle, but it'll be really interesting to see how it behaves with this setup. Sliding reed valve, almost downdraft carb. Should have been sitting at a much steeper angle, but we'll see how it behaves. This is the tuned intake. You can see it's almost exactly the same length. My hopes aren't that high. This configuration was meant for running at constant RPM, not move through the power band. But we'll see how it behaves. I've set the reed valve to open at 12,500 RPM, and then, yeah, let's see. There's a really weird sound here. Maybe something else was wrong after all. Like completely destroyed main bearings. See you next time.